Okay, so we're looking at the same situation, but note that we're starting with not an I equals 1, but an I equals 2. So if we start with I equals 2, 3, 4, 5, 6, we're going to end with a 6. Let's fill that number in. And I don't see any obvious squaring, or let's take a look at the differences. All right, it's not a constant difference, but there is what we call the second differences, and that is constant. And when that happens, that means we've got x squared in there somewhere, I squared in there somewhere. So let's take a look at I equals 2, and we know that 5 is equal to some number. So let's just try by squaring 2. 2 squared, and to get to 5, I'd have to add 1. Let's see if that works with I equals 3. 3 squared plus 1 is definitely equal to 10. So let's just look at I equals 6. We're not going to bother with the rest of them. 37 is definitely equal to 6 squared plus 1. So our pattern here, f of I, is I squared plus 1. And when you see that, it'll be a fairly simple pattern. Okay, on to the next problem. This is a backwards example of a problem we had earlier. Notice that, and let's check, A is 1, so I is equal to 1, 2, 3, 4, 5. Let's put that 5 in there. Notice that my numbers are going up by 1 in the numerator and the denominator. So it just looks like simple addition. So let's look at I equals 1. We have 4 over 3 is equal to, well, with a 1, I would have 1 plus 3 over 1 plus 2 to get to those numbers. All right, let's look at I equals 2. That would give me 2 plus 3 over 2 plus 2, and I definitely get to 5/4. Let's try it with a 5. And that also gets me to the 8/7. So the rest of this problem, so our pattern is I plus 3 over I plus 2. All right, on to the next one. Okay, well, we've got these fractions that seem to be going up. We're starting out with I equals 1. The 3/2 is a little bit of a concern, but I'll tell you what that is a reduced fraction. So let's take a look at I equals 1. So 5/2, and the numerator and the denominators are changing. But when I look at I going from 1 to 2, it looks like my denominator changes by 2. So how would I get to 5 from 1? I don't know. I plus 4. But if it's changing by 2, that's going to be a 2I plus, so 2 times 1 plus 1 gives me that 5. So actually it doesn't. We're going up by 2. So multiply 1 by 2, and let's say add 3, I'll get 5. Okay. The denominator, it could be either 1 plus 2, but look, we're going from 2 to 4, and we're going to forget the middle one, and then, so assume that might be 6, and then from 6 to 8. It looks like we're multiplying by 2 in the denominator as well. Okay, so that'll give me my 5/2. Let's take a look at I equals 2, and is 7/4 equal to, let's say, 2 times 2 plus 3 over, yeah, there's my 7 in the numerator, times 2 times 2. It sure is. So what's going on here is, let's look at I equals 3. We get 2 times 3 plus 3 over 2 times 3. That will give me, 2 times 3 is 6 plus 3 is, that will give me 9/6, which definitely reduces to 3/2. And I'm not even going to worry about the last one because I know this pattern works. My pattern is 2 times I plus 3 over 2I. and we're done with that problem. I'm going to end this video. See you on the next one.